Now the mole is a quantity we're going to use in chemistry to measure atoms. That's what you need to know. If I say mole, it means this number. 1 mole is equal to 6.02 times 10 to the 23rd. You know what a dozen is. So if I say dozen, what does that equal? You're right, 12. And what does a pair equal? It is 2. And what is a mole? It's just 6.02 times 10 to the 23rd of anything. We use moles to represent atoms. So just like 1 dozen means 12, 1 pair means 2, 1 mole is going to be 6.02 times 10 to the 23rd. We can also use the molar mass from the periodic table. You've known this as atomic mass, but what this means is if I take 6.02 times 10 to the 23rd hydrogen atoms and I was able to weigh them, they would weigh 1.008 grams. If I did the same thing with carbon, if I took 6.02 times 10 to the 23rd atoms of carbon and weighed it out, it would equal 12.01 grams. So something you need to know is molar mass is equal to atomic mass. The numbers are. The unit for atomic mass is AMU. The unit for molar mass is gram per mole. And I'm going to show you how to use those conversions right now. Let's jump down to number 1 here. How many moles, that's what we're looking for, of magnesium is 3.01 times 10 to the 23rd atoms of magnesium? We're going to write our unit here. We're going to start just like we would on any dimensional analysis problem. We're going to start with our given, 3.01 times 10 to the 23rd atoms, and we want to write our unit every time. It's not just atoms, it's atoms of magnesium. So atoms mg. The second step in dimensional analysis after you've written your given, just draw your train track. The third step is we bring our unit down. You did this before with dimensional analysis. We're going to do it again. Atoms of mg goes to the bottom, and up at the top we just learned this conversion. 1 mole right here, 1 mole of mg is equal to 6.02 times 10 to the 23rd atoms of mg. So it doesn't matter if it's molecule, atom, ion, formula, unit, whatever it is, they're all going to equal to 1 mole. Atoms cancels out, and I'm left with mole. And the last thing we can do on here is multiply the top, divide by the bottom. Now I want you to be careful in the calculator, because when you enter it in, 3.01, a lot of you like to use times 10 caret 23rd. And if you forget your parentheses, watch what's going to happen here. Divided by 6.02 times 10 to the 23rd. And you get this answer with a 45 on it. That is not correct. Watch what happens here if I add parentheses around this number like we're supposed to. And then you're going to get a different answer. That's because your calculator is trying to divide by 6.02. It's getting an answer. And then it's multiplying by 10 to the 23rd. Make sure that you use parentheses if you're going to do it like that. I would prefer you to do it this way, 3.01. And instead of times 10, we're going to hit second E right above the 7. It's the comma, the EE button. And it'll look like that. And then we just type in our exponent, 23. Divided by 6.02, I'll show you again, second EE, which is right above the 7 on the comma, 23, and that is going to equal 0.5. And then, since we have 3 sig figs, it's going to be 0.500 moles mg. I'll work one more on the back for you and show you how to do the other one. So let's go and flip it over, and we're going to work number... We'll work number 1. How many moles are in 88 grams of carbon? We're going to start this one the same way we just did before. 88 grams of C. Write your given, write everything, the unit and the atom. We're going to draw our train track. We're going to bring the unit down. Look how quick you can go once you practice with it. And what do we want to go up to? We want to go up to moles. Moles of C. On the previous page, we just learned that molar mass is the same thing as atomic mass, and it's right here. 1 mole is equal to the mass from the periodic table. And we can use that as a conversion here. 1 mole is going to be the mass from the periodic table. Carbon is going to be 12.01 grams of carbon. Grams cancels out. I'm left with mole. That's what we want. We're good. Multiply the top, divide by the bottom. 88 times 1 divided by 12.01. We hit equals and we get this nice long number, but we can round it to 2 significant figures. My final answer is going to be 7.3 moles of carbon. And that makes sense because if 1 mole is 12.01 grams, then 88 grams has to be more than 1. So we get this number of about 7.3. The last thing I want to point out here, if you look at mole, the number is 1 mole. If I flip it back over to this side, the number is 1 mole. It's always going to be a number 1 next to mole whenever we're converting to a different unit. And you can use that trick to help you make sure you get those problems right.